Welcome back to our discussion of adjoint of a linear operator. In this lecture, we will discuss least square approximation and minimal solution to system of linear equations. Before going to the main topic, let me discuss some important concepts that are required to establish the discussion of least square approximation and then minimal solutions. So, whenever we have a matrix, suppose let me write side by side. Suppose A is an M cross or an element of M cross n over the field F. So we can always see this matrix as a linear operator. We have already discussed that every matrix can be seen as a linear operator and every linear operator can be represented in its matrix representation, right? So you can consider this particular matrix as a linear combination and that linear combination defined as LA, that is the left multiplication operator, and that defines from Fn to Fm such that La of x is same as A of x. Okay, जब भी A का डायमेंशन m क्रॉस n है, then you can think this A as a linear transformation from n to m. Okay, that we have written Fn to Fm. So this x must be an element of Fn, and whatever the Ax is coming, that is part of this Ax is an element of Fm. तो जब हम इस मैट्रिक्स ए की रेंज की बात करेंगे तो दैट इज सिमिलर टू द रेंज ऑफ दिस लीनियर ऑपरेटर एल ए एंड दैट विल बी सब स्पेस ऑफ एफ एम. If we talk about the kernel of this linear transformation, then that will be, or the null space of this linear transformation, then that will be subspace of fn. ठीक है, ये हम यूज़ करने वाले हैं. Then you have a second concept about the inner product in fn. Okay, so fn में हमेशा हमने इस तरीके से डिफाइन किए हैं in fn inner product कैसे डिफाइन किया है, दैट x कोमा y इज इक्वल टू y स्टार x. Okay, now this y star is conjugate transpose of this column vector y. Okay, see, here we are having n, since when we discuss a matrix A, then it has m, then n. So we have different kind of fields like f to the power n, f to the power m, like that. So to distinguish between the norm for a particular vector space, so we use a notation here that will specify कि ये कहाँ पर हम बात कर रहे हैं. So we use this n here. So if we are writing the inner product then n and n, then that means कि ये inner product fn में है. Likewise, if we are having x comma y then m, that means we are talking the standard inner product in fm. Okay, so based on these two concepts, let me define two lemmas. The lemma 1 says lemma 1, and this says let A be M cross n matrix over the field F. Okay, and suppose X be any element from Fn and any Y in Fm, then we have that inner product Ax comma y in M, that is same as inner product x comma a star y in n. Now this a star is the conjugate transpose of a. ठीक है, तो आप यहाँ पर ही देख पा रहे हैं, थ्रू दिस लेमा वी कैन go from inner product in M to inner product in N. Okay, the proof is quite simple. We just use the concept of adjoint. So proof says इस इनर प्रोडक्ट को अगर हम डायरेक्टली कंसिडर करें देन ए एक्स कोमा वाई इन एम, that is same as if we apply this definition of standard inner product, then that will be equals to y star a x. Okay, now this y is column vector, or you can say column matrix. This is a matrix, this is a matrix, and x is also a column vector, right? You can write this as y star. Using dissociativity, you can write y star x. Okay, now this is our matrix that is applying on this x, and you can write this, the bracket is a star y, then put this star here. Okay, if you think this a star y star x as a inner product, then this is similar to x comma a star y, right? क्योंकि जब हम इसका conjugate transpose लेंगे and then we multiply at the initial stage, then we will have the same kind of configuration here, right? So x comma a star y, that is equals to ax comma y inner product in M. Now you can see this x is an element of Fn a star y, that is if a is M cross n matrix, M cross n matrix over F, then you can consider this L A from Fn to Fm, right? And if you have the conjugate transpose, that means A star, then this will be element of M n cross M over F, क्योंकि ट्रांसपोज लेंगे तो कॉलम और रोज आपस में इंटरचेंज होंगे. In that case you can consider LA star, that is a linear transformation from Fn to Fm to Fn, राइट? तो इसका जो रेंज सेट है वो एफ एन में जा रहा है. तो जैसे यहाँ पर ये जो y आएगा, दैट मीन्स एल ए स्टार ऑफ y, दैट इज सेम इज a star y. Now this y is coming from Fn and the resultant value will be in Fn. So this x and this a star y is in n. So let me write here n, so that we can distinguish कि ये inner product Fn के लिए define है और ये inner product Fm के लिए define है. Okay, so इस तरीके से we can establish the result between these two norms. Now let me come to the next lemma, and it says lemma 2. It says let A is M cross n matrix where entries are coming from the field F, then rank of A star A is same as rank of A. ठीक है, जब कभी भी आप किसी भी मैट्रिक्स के लिए रैंक का आइडेंटिफिकेशन कर रहे हैं तो उस केस में वी कैन गो फ्रॉम द रैंक नलिटी थ्योरम. ओके, you know the rank nullity theorem. Rank nullity theorem, it says अगर हमारे पास t कोई एक लीनियर ट्रांसफॉर्मेशन है from v, let me write the dimension as well. Okay, vn to vm, this is a vector space of dimension n, this is a vector space of dimension m. Then dimension of vn is same as the rank of t plus nullity of t. This is rank nullity theorem, or you can write this n equals to, you can use this row and plus neta. So this is the rank nullity theorem. Now here we are asked about the rank of some matrix, and every matrix is linear transformation. तो यहाँ पर अगर हमें रैंक डिस्कस करना है देन वी कैन थिंक अबाउट दी नलिटी, बिकॉज नलिटी के लिए हमें वो सारे एक्स आइडेंटिफाई करने हैं, वो सारे एक्स आइडेंटिफाई करने फ्रॉम दी वेक्टर स्पेस वी एन सच दैट टी ऑफ एक्स इज इक्वल टू 0. तो ये सारे जो एक्स है दैट विल बी इन नल स्पेस ऑफ टी. ओके, लेट मी राइट नल स्पेस ऑफ टी. ठीक है, तो ये कैलकुलेशन करना मोर सिंपलर है देन आइडेंटिफाइंग द रैंक. सो आई एम गोइंग this way to prove this particular lemma. ठीक है? So let me also clarify that when we discuss this rank of A star A and rank of A, so what about their domain vector space? So if A is M cross N matrix, then you can see let given that A is in M cross N over F. ठीक है? Then what about the linear transformation related to this A, that is the left multiplication, that will be from Fn to Fm such that La on x is equal to A time x. Okay, now you have that. What about A star? So this is matrix from M, N cross M, entries are coming from the field F. Then you can consider L A star, that will be from Fn Fm to Fn. ठीक है, अब अगर यहाँ पर आप L A Y लिखेंगे then that will be A L star star Y. Now this Y is an element of Fn. ठीक है, what about A star A? So this is M cross N and this is N cross M. So this will be in M N cross N over the field F, right? This will be in a square matrix. Okay, so then you can consider the left multiplication operator related to this A star A, that will be from Fn to Fn. So L star A on X is same as A star A on X. ठीक है, now writing these over linear transformation, what I want to say कि अगर हम इस A के लिए बात करें, you can consider this. Okay, this LA, that means the linear transformation related to this A has the domain Fn. Okay, and this matrix A star A has also the domain Fn. और जब हम रिंग नलिटी थ्योरम लिखते हैं तो वहाँ पर हम डोमेन का डायमेंशन ही डिस्कस करते हैं. तो अगर हम इस एल ए और एल ए स्टार ए के लिए ये प्रूफ कर दें कि इन दोनों का नलिटी सेम है तो उनका रैंक भी सेम हो जाएगा, क्योंकि यहाँ पर इनका डोमेन वेक्टर स्पेस का डायमेंशन सेम है, दैट इज एन एंड एन. Okay, so to show that the rank of A star A is same as rank of A, it is sufficient to show that the nullity of A star A is same as nullity of A. ठीक है, so what can I write? So the domain vector space for LA and LA star A are same. Okay, then we need only show that for x belongs to Fn. Okay, इनपुट हमेशा Fn से ही है. We always have that A star A on x is equal to 0 if and only if our A on x is equal to 0. ठीक है, इसका मतलब क्या है कि A स्टार A जिन x पर 0 दे रहा है उन्हीं पर ये A भी 0 दे रहा है, और जिन कॉलम वेक्टर x के लिए A ऑफ x की वैल्यू 0 आ रही है, सेम उन्हीं x के लिए A स्टार A भी 0 दे रहा है. इसका मतलब A स्टार A और A का नल स्पेस सेम हो जाएगा, एंड व्हेन द नल स्पेस ऑफ A स्टार A एंड A इज सेम, दैट will define that nullity of A star A is same as nullity of A, and the nullity, if the nullity is same, then from this discussion we can say the rank is also same. Okay, so let me conclude this. So if we choose A star A, then the A star, sorry, AX equal to 0, then this will be automatically 0. Okay, so you can write AX equal to 0. This implies A star A x is equal to 0. ठीक है, क्योंकि अगर ये जीरो वेक्टर है तो ए स्टार ऑन जीरो वेक्टर विल बी जीरो. ठीक है, कन्वर्सली यू कैन राइट लेट a star a x is equal to 0, then this must implies a x equal to 0. ये हमने प्रूफ करना है, शो करना है. ठीक है, अब अगर ये a स्टार ए एक्स अगर ज़ीरो है तो अगर हम इसका किसी भी x के साथ इनर प्रोडक्ट लेंगे इन दी n, then that will be the 0. So if this is equals to 0, a star a x is equal to 0, then this implies that inner product a star a x with x that will be equals to 0, क्योंकि ये वेक्टर 0 है तो 0 का किसी भी वेक्टर के साथ हम इनर प्रोडक्ट लेंगे तो वो 0 रहेगा. ओके, now you can see this x is in fn, this a star a x is also in fn, so this inner product is in fn. Okay, now from the previous statement, if I write the star on this x, then that will be the inner product in fm. So if I says, let me write this as a star on ax comma x in n, that is equals to 0. Now whatever the matrix is here, I'm going to take this complex conjugate transpose. So I will have ax comma then a star star of x, that is equals to 0. Now conjugate transpose of conjugate transpose is the same matrix, so this will be ax comma a x equals to 0 in, that is in m. Okay, that is also in m. ओके, ये यहाँ पर हमें बताना ज़रूरी है कि ये इनर प्रोडक्ट एफ एन में है, ये इनर प्रोडक्ट एम में है, एफ एम में. ठीक है, अब हमने ये देखा था कि अगर किसी भी वेक्टर के लिए इफ़ वी आर हैविंग दिस इज इक्वल टू 0, देन दिस इज पॉसिबल इफ एंड ओनली इफ एक्स इक्वल टू 0, राइट. सो आई कैन राइट दिस इज पॉसिबल इफ एंड ओनली इफ ए एक्स इक्वल टू 0. यहाँ पर हमारे लिए जो इनपुट है वो एक्स है. सो वी हैव सपोज्ड ए स्टार ए इक्वल्स टू 0 एंड नाउ वी आर एबल टू शो दैट ए एक्स इज इक्वल टू 0. ओके, सो null space of a and a star a are same, दोनों का नल स्पेसेस सेम है. सो null space are same, therefore you can say nullity of a is same as nullity of a star a. This n represent the dimension of null space. Okay, this is dimension of null space. ठीक है, अब अगर ये n a सेम है तो आई कैन से दिस इम्प्लाइज n किसका डायमेंशन है, एफ एन का. सो आई कैन से n माइनस null space of a, that is same is n minus nullity of a star a. Okay, from the rank nullity theorem you can say n minus nullity of a, that will be the rank of a. So that is rank of a is same as rank of a star a, and this is due to by dimension theorem, or you can say by rank nullity theorem. Okay, and we can write this as rank of a is same as rank of A star A. So this is how you can prove this lemma.